Whenever we think of humans going out and colonizing space, like leaving Earth and actually building homes somewhere else, we generally think of planets, which is a mistake. It's a total, absolute mistake, as the numbers are just compelling. The numbers simply say that we are not going to live on planets, we are going to build space habitations. Take Mars, for example. Mars is the obvious candidate for colonization because, well, firstly, it's in our solar system. Secondly, for a very long time, people looked at it through their telescopes and they saw what they thought were canals, and then people wrote books about Martians, and so it seems like the obvious place for us to build our next home, but it is totally wrong. And you realize that it's totally wrong once you have the design for a space habitation. I've already discussed in this book the design for space habitations, and there are a couple of videos also which talk about how these space habitations will be built. And importantly, those videos have a number, and that number is that there will be a mass of about 1.42 trillion kilograms needed for building a space habitation for 50,000 people. So what does that imply for Mars? Well, you can go and live on Mars. You can try to colonize Mars. However, you are going to face a number of very difficult problems. Okay? So here are just a list of the problems why space habitations are so much superior to living on celestial bodies. Okay. For example, if you're on Mars, it's almost impossible to provide artificial gravity which is equal to Earth's gravity. And now you have to remember, we evolved on Earth. Our bodies are built to develop in an environment of Earth gravity. So you just can't go somewhere and live somewhere else where the gravity is different and expect normal development to take place. It may happen, but it's unlikely. If you were to live on Mars, it's going to be much harder to provide radiation shielding. You have in the video on space habitations, I've already discussed how much shielding you require, and according to NASA, and that shielding is it's considerably thick. So if you're on Mars, you'll have to live under that thick roof. You have to build a very thick roof over your head, and you hope that it doesn't collapse and fall and bury you under it. Okay, so you're stuck in a place where you have a thick roof, you don't have the proper gravity. However, those things are really not the point. The point is sustainable carrying capacity. How much carrying capacity does Mars provide compared to how much carrying capacity will space habitations built using the mass of Mars, how much will that capacity be? Now, Mars is quite yummy. So, you can it can be disaggregated and used to build space habitations. It's the escape velocity from Mars is only 5 kilometers per hour compared to about 11 kilometers per kilometers per second compared to 11 kilometers per second for Earth. So doesn't require a whole lot of kinetic energy to get from the surface of Mars to space. Okay, the mass of Mars, now we are coming to the real point. The mass of Mars is about 6 into 10 to the power 23 kgs. If you were to break this up, you could have 452 billion space habitations. And why is it that you're seeing this number here? What is the background to this number? The background to this number is the calculations for the amount of mass it would need to build a space habitation, which was actually discussed in the earlier videos, and that was 1.42 trillion kilograms. So Mars, if you were to break it up and you send it to space, you could be able to build 452 billion space habitations, and each space habitation would have 50,000 humans living in them, which is about 22,000 trillion humans. Compare that with if you were to actually colonize Mars, how far would you get? Well, I mean, very optimistically, like something like Earth. Mars is a lot smaller, so it really won't be like Earth. But suppose you even got to Earth, and how much is that? That's 10 billion. So you, on one hand, have 10 billion carrying capacity if you colonize Mars. On the other hand, you have 22,600 trillion. So that's like 2.6 million times more than 10 billion. So you can actually provide home for 2.6 million times more humans if you were to break up Mars and build space habitations. And can you actually break up Mars and build space habitations? Well, then there are some issues about, okay, it comes down to energy, and it comes down to how much energy does Mars receive, and there are some calculations for the energy per unit time in terawatts, how much it does. So the power available from solar panels, if you cover about 50% of Mars, will be 6,495 terawatts. The amount of energy needed to spend 1 kilogram from the surface of Mars to outer space is about minus 12.63 megajoules, which tells you that to send 1.42 trillion kilograms to outer space from Mars using this energy would require about 3,600 seconds. That's about an hour. So you can use the solar energy which is falling on Mars to send material to outer space to build space habitations at the rate of 1 space habitation every hour. Now, there are some other more precise calculations which are done in the book, so you'll have to get the book for that. And then similarly, we are going to eat Venus at someday. Okay, yeah, by the way, let me just say that, so all of Mars will take about 52 million years to eat, and then I think after Mars we'll move on to Venus, or maybe we'll do it in parallel. And Venus has some challenges because it of course is much more larger than Mars. However, its temperature is 464 Celsius, which is very hot, and it also has a very thick atmosphere, so thick that only 10% of the solar insolation reaches the surface of Venus. So there'll be challenges, but again, who knows what our technology will be. Well, I know, or I believe I know. Our technology will be 100 years, 1,000 years from now. And I think the way we'll proceed with Venus is we shall first siphon off the atmosphere, use the atmosphere to for whatever ways we can use it in our space habitations. And we will then, Venus's atmosphere is mainly carbon dioxide. And carbon dioxide and hydrogen together give you hydrocarbons, which can be used as many things. It can be used as building material, and also the atmosphere of Venus will be quite useful to for the purposes of space habitations. And remember, this is all automated. This all is going to be done by robots, so we won't really have to go and take it a little bit at a time. No, this will be done by massive machines with minimal human input, and that's where we shall be. In a few million years, you'll see that the atmosphere of Venus is being siphoned off, and then after the atmosphere has been sufficiently reduced, we'll actually be able to put mining machines on the surface of Venus and then eat Venus, just like we'll eat Mars. But we'll eat Mars first, because Mars is much more easy to mine. It barely has any atmosphere. Its escape velocity is low. So there you have it. We are not going to colonize Mars, we are going to eat it.